Hi everybody, in this video we're going to go over test number 3. So for the first question, it's easiest to see if I show you the cross sections of a cone on the computer. So I'm just going to pull that up and we're going to see which one is not a cross section of a cone. So let me pull up over here my cone cross section. So, oops. So I already see that I can get a circle, so that's pretty clear. Okay. If I rotate it this way, then I see which answer choice is that. That's answer choice 3. So already we have answer choice 3 and answer choice 4. So I'm between 1 and 2. And if we go completely vertical, completely perpendicular to the base, we get a triangle. So the one that you cannot get is answer choice 1. You cannot get a square from this cone. Okay, moving along, we have a rectangle that is rotated into a 3D shape. Anytime you take a rectangle and you spin it really fast, you rotate it until it becomes a 3D object, it's going to become a cylinder. If you start with a rectangle, it will end up being a cylinder. So the answer to number 2 is 3. Moving along, we have a hexagonal prism and we're intersecting it perpendicular to the base. So here's my hexagonal prism and here's a visual of perpendicular to the base. It's like a rectangle or a square. Parallel to the base, which is horizontally, that would be a hexagon, which a lot of you chose. But perpendicular to the base is the same as the faces, not the bases, because you're slicing it vertically. So that would be answer choice number 4. Okay, moving along. Once again, if you start with a square or a rectangle and you rotate it until it becomes a 3D object, it's going to become a cylinder. So choices 1 and 3 are already eliminated. The square has side lengths of 7 inches and all the sides of a square are equal to each other. So when we're spinning it really fast to make the cylinder, it's going to look something like this. I'm a terrible artist. I do apologize. But the important part is that we can see that the height is 7 and the radius is 7. So that would be answer choice 4. The radius is with 7. The diameter would actually be 14. It would be 2 of those 7s together. Okay. I think people were overthinking this one way too much. So AB is perpendicular to plane AEFG. And let me just highlight plane AEFG. So which plane must be perpendicular to plane AEFG? Well, if this line is perpendicular to this plane, then any plane that has this line in it is also going to be for sure perpendicular to this plane because this line is perpendicular to this plane. So once again, if the line is perpendicular to the plane, then any plane containing this line is also going to be perpendicular to this plane. So looking through, I already found it. Answer choice 1, A, B, C, E, that contains line AB. Because once again, if line AB is perpendicular to this plane, then the plane containing that line also has to be perpendicular to that plane. There we go. Okay, so the volume of the sphere, so let me write my formula. The volume is 44.6022 cubic centimeters. And we're finding the radius. On my calculator, I'm just going to get my fraction button, and I'm going to take 44.6022, and I'm going to divide by 4/3 pi. That's the same thing as first multiplying the side by 3 and then dividing by 4, but you can do it in one step by dividing by 4/3. So let me get my fraction button. I just clicked the wrong button. 44.6022 divided by 4/3. And then this number needs to be divided by pi. And what I got is that r cubed is equal to 10.6479. So what we have to do now is take the cubed root of both sides to get r by itself, to cancel out that exponent of 3. So I'm going to hit the math button on my calculator. And number 4, when you hit the math button, is the cubed root. So I'm going to take the cubed root of 10.6479. And I get 2.19, which rounds to approximately 2.2. Okay, moving along. So this actually was a question from class that we went over in class. So we had done this one before all together. The pyramid is a square pyramid. Volume of a pyramid is 1/3 area of the base times the height. Some people are still thinking that this is lowercase b or base. Uppercase B does not mean base. It means area of the base. Now, the square base is an 8/8 square. And we know that if we have an 8/8 square, we find the area of the square by doing 8 times 8. So I'm going to replace capital B with 8 times 8 because the area of the square base is 8 times 8 times the height of the whole pyramid, which is 3. So I'm going to replace that h with 3 because the height of the whole pyramid is 3. Let me put this into my calculator. 1/3, 8, 8, 3, and I got 64 cubic feet. Then the bottom also occupies space. There was a hint that said that over here. That hint was there to be nice. On the Regents exam, there was no hint given for this question. So the bottom would be area of the base times the height. The base is also a square because it's 8/8. So we have area of the base, 8 times 8, times the height of this bottom portion, which is 9. So on my calculator, let me do 8 times 8 times 9. And I got 576 cubic feet. If I add these two together, I get a total of 640 cubic feet. Okay, so this question had some words. It wasn't that bad though. So we have the old container and the new container. And as some people were taking the test, I noticed them labeling old and new container. That's a good idea to keep track. So this was bolded over here on purpose. We bolded that for you guys. Same amount in both of the containers. That means that they have the same volumes. So we are given that the new container's height, so from top to bottom, the height is 16. And what we need to do is we need to find the side length of the base of this container. So it's a cube, a rectangular prism with a square base. So we need to find the side length of this square base. Let's first find the volume of the old container. So that's a cylinder. So that's pi r squared height. So it tells us the height's 18 and the diameter is 14. So that means the radius is 7 and the height is 18. I'm going to put this into my calculator. Pi 7 squared times 18. And I got approximately 2770.885. I'm going to keep a couple of decimal places until my very last step here. Okay. Now for the new container. It's a rectangular prism with a square base. The volume of any prism is area of the base times the height. And since this has a square base, whatever the two sides are of that square base, we would multiply length times width, or side times side. So we can write that volume as side squared, or side times side, or length times width, as long as you recognize that they're the same number. And the height was given to us as 16. So we were told that both containers hold the same amount of almonds. So the volumes are equal to each other. So I'm just going to set those equal to each other. So I'm going to get S by itself. The first thing I'm going to do is divide both sides by 16. So I have that S squared is approximately 173.18. Then to get S by itself, I'm going to take the square root of both sides. And it does say to round to the nearest tenth of a centimeter. So after I take the square root, whatever I get for my side length, it's 13.1597. I'm going to round to the nearest tenth. Okay. So we're told that the chocolate covered almonds are displayed on a shelf, and I'm a terrible, terrible artist, but I'm going to do my best to draw you a picture of this shelf. And the dimensions of the shelf are 80 centimeters long and 60 centimeters wide. The shelf can only hold one layer of new containers. So we're not stacking the containers on top of each other. There's not going to be a bunch of layers. It's only going to be one layer. So I don't know how many containers can fit. That's what we're actually trying to find. We're trying to find the maximum number of new containers that can fit. And the new containers are these ones over here. The rectangular prism with the square base, which is basically a cube. So we're not stacking them. We're putting them in one layer, a single layer. So, and I'm not a good 3D drawer. So basically, we're finding how many of them can be put on the shelf, the maximum number that can fit there. So that's just a visual so you can understand what we're doing here. So since we're not stacking them, the height doesn't matter. It's not going to be impacted. It doesn't matter how high each container is because nothing's going on top of it. It's just one layer. So what's going to be impacted here is the length and the width, because the length and the width are going to determine how many of those containers can be put on the shelf, because it can only fit however many that fit 80 centimeters the long way and however many that fit 60 centimeters widthwise. So once again, height's not going to matter here because we're not stacking them. What's going to matter is length and width of the base of these containers. And we know that the base of these containers are squares. And we found in part A that the length of the sides of the base are 13.2. So each of the bases on these rectangular prism containers is 13.2. So what I'm going to do is I'm going to take the length that can fit on the shelf and divide by the side length, because that's the width of the base of each container. And the length of the base of each container. I'm talking about length right now. And then I'm going to do the same thing with the width. I'm going to divide by the width of the container base, of the base, the base of the container. And the width of the base of the container is once again 13.2 because this container has a square base. So I'm going to put these onto my calculator. 80 divided by 13.2. That's approximately 6.06. And 60 divided by 13.2. That's approximately 4.55. So I'm going to do length times width because length and width make up the base of the containers. So if I do length times width, I'll find out how many containers can fit in this space. So multiplying them on my calculator. Oh, and before I multiply them, it's maximum number. So we can't have parts of a container. So I'm just going to write this one as 6 because we can't have that 0.0 whatever of a container, 0.06 of a container. 6 is the maximum number of containers. We don't have 7, we have 6, and that's it. Over here, we can't have 4.55 of a container, but we don't yet have enough space for 5 containers on the shelf. So the most that's going to fit here is 4 containers. And then when I multiply together, I get 24. 24 is the maximum amount that can fit on the shelf. This also works if instead of dividing by 13.2, if instead you divide by 14, because there can't be like 13.2 of a container. So if you round up to 14 to the next whole number, and you do 80 divided by 14 and 60 divided by 14, you'll get the same thing when you multiply together as well. You'll get 24 when you multiply together. So that way works as well. But I think this way makes the most sense. And sorry that this part of the video is taking too long. I just want to make sure we're all good with it. I think this way makes the most sense because the length and the width of the base is what's impacting what can fit on the shelf. So I think it makes more sense to divide the length and the width by the length and the width of the base and round down because we can't have part of a container. And once you round down, multiply together, 24 is that maximum number that you can get. Okay, so we have to use Cavalieri's principle here. So Cavalieri's principle says if the base areas and the height are the same, then they will have equal volumes. You should use information from the question. It shouldn't just be really general, like base area and height are the same, so they're equal. Like it should be something also with information from the question in it. So I'm going to write here, since the two stacks of quarters both have the same height of 23 quarters. So I'm being specific to the question. I'm mentioning the 23 quarters. And since the radius of each quarter is the same, so the base areas will be the same. The volumes are the same, even though one stack forms a cylinder and one doesn't. Yeah, so the reason why the base areas are the same, the area of a circle, because that's what the base is here, it's a circle, the area of a circle is pi r squared. So if the radiuses are the same, which they are because it's the same coin, it's the same quarter making up each stack. Quarter's a standard size, has the same radius every quarter that you get. So since the circles, the coins, have the same radius, they have no choice but to have the same base area, the same area of the circle. And they also have the same height, 23 quarters, so that makes the volumes the same. This question people actually did very well with. So the candle is in the shape of a cone. So that is 1/3 pi r squared height. It tells us in the question the diameter is 3 inches. So that means the radius is 1.5 inches. And the height is 8 inches. I'm going to put this into my calculator. 1/3 pi 1.5 squared times 8. And I got 18.8495. It says 100 candles. So some people rounded here to 19. No, don't round until your very last step. It impacts your answer and it will be a rounding error. I'm not going to round yet. I'm going to first multiply by 100 on my calculator because we're finding the volume of 100 candles. And that is 1884.955. Now I'm going to round according to the question because I'm done with the question. So to the nearest cubic inch, it is 1,885 cubic inches. If you rounded early to 19, you would have had the wrong answer. You would have had 1900. Okay. So in the next part of the question, we're given this number that has 2 units. One unit's the mass unit, the other is the volume unit. So that tells us this number is the density. So plugging into my density formula, remember density equals to mass over volume. We have 0.52 ounces per cubic inch. We are looking for the mass, and we already have the volume of the candle from the previous part of the question. The volume units cancel out. Oops. So the mass is equal to, all we have to do is cross multiply, 0.52 times 1885. And I got 980.2 ounces. Now it says the wax costs 10 cents per ounce. So to find the cost of the wax, I'm going to multiply by 10 cents. And that gives me that it would cost $98.02 to buy the wax for the 100 candles. Remember, this 1885 was already the volume for 100 candles. So this cost, since we use the 1885 here, is the cost for 100 candles. We do not have to multiply it by 100 again. We already did that when we found the volume. Profit means how much Walter made after you account for what he spent. So Walter charges $1.95 for each candle. So if he sold 100 candles, Walter made $195. Now let's talk about what he spent to make those candles, to make that money. He spent $37.83 for molds. And in part B, we learned that he spent $98.02 for wax for the candles. So if I add his expenses, the cost of the wax, which is $98.02, and the cost of the molds, which was $37.83, that's $135.85. So that needs to be subtracted from the money that Walter made. So let me do that. Let me subtract on my calculator. And we see that Walter made a profit of $59.15. Okay, let's take a look at the extra credit. We have big right triangle with two smaller right triangles inside. And we also know from the question that there's an altitude drawn to the hypotenuse of the big right triangle. Whenever you see this situation, big right triangle with two smaller right triangles inside, we're going to think leg rule or altitude rule. It's a right triangle altitude theorem question, always when you see this kind of diagram. So it's already labeled, and I want to find JG. JG is part of the hypotenuse. And I don't know anything about the altitude, and I'm not finding the altitude. But what I do have is this leg. So I'm going to use the leg rule. So what the leg rule says is that the leg is the mean proportional. That means it gets written twice in your proportion so that it's cross multiplied by itself. And it's the mean proportional between the whole hypotenuse, which would be 16 plus x, and the part of the hypotenuse directly below the leg that you're using, which would be x in this case. Cross multiply. 16x plus x squared. 15 times 15 is 225. We have a quadratic. That means the highest exponent's 2. So I need to solve this either by factoring or the quadratic formula. But generally, all the questions that they give in geometry can be solved by factoring. So you don't need to bother with the quadratic formula, which is a hassle to me at least anyway. I'm going to make this equal to 0. Okay, now I'm going to factor. Remember, you can use your calculator to find factors. We can type in 225 into our y equals, divided by x, just x. X squared is for radicals. So divided by x, hit second graph to get your table of values. And I'm looking down and I'm trying to find two factors of 225, of negative 225, that multiply to give me 16. Sorry, that add to give me 16. And I found it. So one of those factors is 25, and the other one is negative 9. 25 and negative 9 multiply to give us negative 225. And if you add 25 and negative 9, you get positive 16. So that means one of our x values is negative 25, and the other one is positive 9. In geometry, we reject the negative because we're talking about real-world situations, triangles. So JG is 9. Now, we need to find the length of HJ. HJ is the altitude. Let me use a different color. And we know that the altitude is the mean proportional. That means it gets written twice so that it's cross multiplied by itself between each part of the hypotenuse. So one part of the hypotenuse is 9, we just found that. And the other part of the hypotenuse is 16. So let me cross multiply. 16 9 is 144. And that's equal to y squared. So we have 12. HJ is 12. There we go.